Our agenda is on the screen. Warm up. We had a pop party instead of turning in last night's home play. And today we're moving on. We're moving on to transformations of log functions. So good practice last night. And your home play for tonight is pages 771, 772. I'll upload those in a little bit. Also for the signature, that screenshot of the that you have the study guide a month ahead, I'll pick that up tomorrow because I forgot to add my period 2. So I just want to make sure that they have the extra day to turn that in. So I'm giving you the extra day. Thank you, Mr. Q. You're welcome. So our objective for today, I can graph and transform logarithmic functions. I can graph and transform logarithmic functions. I can graph and transform logarithmic functions. All right. So copy the objective, get a Cornell note. I'll give you a little bit of time. Go. All right. So by now you should know the definition of log functions. Tell your neighbor, please. All right. So yes, they are inverse of exponential functions. So we covered this yesterday. Part of the home play was to make logs into exponential, and from exponential to log, and then to solve, and then to evaluate. Yes? Yes, Mr. Q. All right. So for today, I want to get started first with a graph. Copy this, please. On the left side, we have a log. On the right side in red, we have an exponential. So put them side by side, and we're going to start graphing the exponential first. So I'll give you about a minute so you can set up your tables. Don't fill them up yet. We'll do this one together. But get a Cornell note ready, please. I mean a coordinate plane. Go. All right. Here we go. So some of you are already done setting up. Some of us are still finishing up. But I'm going to start with the red one first. The red function is f of x equals 2 to the x power. That's an exponential function. So we know how to graph that because we need to start with our asymptote, which is what? What do we need? An HA, which is y equals 0. Okay, so y equals 0. There it is. Okay. Next, remind your neighbor, what are the 3 points that we use for exponential functions, for the parent function? What are the 3 points? Looks like Caleb's got it. Very good. Diego Rosa's got it. All right, Diego, what points? 0, 1. What is it? 1, 2, 2, 4, and we're going to go one more. 3, 8. All right, write those in here. 0, 1, 1, 2, 2, 4, 3, 8. Plot those. And let's graph our exponential function. Okay. Pretty good. All right. You all ready? Thinking cap on. Here we go. According to what we said in definition for logs, look up to the screen. Logs are the inverse of exponential functions. So if that's true, what would I write for my last point, but as a log? What would I write for my last point? All right. Tell your neighbor, please, before I get someone to help us, what would I do to my last point? Anaya. If it's an inverse, what do we do? Frida. You switch it, so what would I write? 8, 3. Let's see if it's true. Let's write our log, guys. This one. S inverse blank equals log 2 blank. So instead of x, what am I going to use? 8. Let's see if it's true. Let me zoom in. Okay, according to last night's home plate, we know what to do next to solve. What would be my next step right here? Everyone, what would be my next step? Change to y, yeah. So this is log 2, 8. Continue, Diego Romo. So, thank you. Continue, Alyssa. To the third, so that means y equals 3. So when x is 8, what is y? 3. Let's see if it's true. Did we write that? Yeah! Let's go! So therefore, tell your neighbor what else to write here and here. What else do we write? Everyone, what do we do? Switch them, right? So that's 1, 2, 4, and these will go 0, 1, 2. Let's plot these points. 1, 0. 2, 1. 4, 2. Oh, 4, 2. And 8, 3. Look how pretty that looks. Does that look like an inverse? Yes, it does. All right. So since we're already in that mode, here goes another $1 million. Yes? Good question. Look up to the screen, guys. How can we have this point on the HA? Well, because this HA is for the red one. Does everyone understand what we're saying? Diego said, Mr. Q, why can't we place a point on this HA asymptote if we're not supposed to touch it? Because this red one belongs to the red function. So in that sense, here it goes. The exponential has an HA. If the logarithm is an inverse of the exponential, what shall we have here? What do you guys think? VA, that is correct. X equals 0. So I want you to plot 0. And let's plot the asymptote. And notice, Diego, none of the points that we plotted touch that asymptote. That make sense? Yep, because it's an inverse. Well, I just wanted to show you where it comes from to make sure you understand that the logs are inverses of exponential. Did that make it clear, or do we need another one? Caleb, do we need another one or we're good? We need another one? Okay. All right, before we get to the other ones, copy these, please. Underneath that, f of x equals log 216, f of x log 100, and f of x ln x. And today we're introducing two more logs, and we're going to call them parent functions. This last one, f of x ln x, the ln stands for natural log. We can talk about that in a little bit. But natural log means that this base is going to be replaced by the letter e. Look up right above it. I want you to write the letter e, approximately 2.718. So to clarify on these two, let's do the work for this one to make sure we got it. And I know I'm being a little bit redundant with the work, but just to make sure we got it. Tell your neighbor what to do from here to solve. What do I do there to solve? All right, good conversations. JP, what do I do? No, to solve. We're not graphing yet. Close. Help him out, Jaden. Yes, change fx to y. Log 216. Continue, Joel. Two to the other side. To the what? Equals. $16. Continue, Alessandra. 2 to the y equals 2 to the what? Therefore, see what I did? Therefore, y equals 4. All right, and that was last night's home play, yes? Okay, let's go with this one. What do you guys notice from this new one compared to the ones that we've been doing since yesterday? Tell your neighbor, what do you notice? It doesn't have a base. Whenever you get a log that does not have a base, I want you to write right away base 10. That's something that's automatic when it comes to logs. When it doesn't have a base, you write 10. And the process is the same. So help me out. Continue from there. Noel, go. Y equals log 10, 100. Continue, Christopher. 10 to the equals 100, okay. So therefore, 10 to the y equals 10 to the what, everyone? Second, so y equals 2. All right. Not bad. Not bad at all. Good thing you're taking copious notes. Ivan. All right. Next, whenever you have this one with a natural log, instead of writing any number for a base, we're going to write the letter E. Letter E. And the process is the same. All right? Diego Rosas. What? LN. Thank you. Continue, Jose. Thank you, and we'll stop right there. All right, so if you notice, the process is the same. However, underneath here, let's write the parent function for this one. So we agree that the parent function for these kind is f of x equals log 2 of x. That's the parent function. How about the parent function for this one? F of x equals log x. And of course, if it doesn't have a base, we know that when we get started with a work, we put a what? 10. And this one, the parent function is as is, L and x. That's the parent function. All right? So I want you to copy the graph so you know what they look like and their tables. Underneath that, here they go. Copy this. I'll give you some time. And for the log base 2, I want you to add one more point, which is 4, 2. Copy that. Go. All right. So let's see where we're at. For the parent function, f of x equals log base 2 of x, the point that I want you to use from now on when I ask you to graph the parent function are this one, and this one, which means 1, 0, 2, 1, and 4, 2. Now, one quick note, look up. Notice that all parent functions have the point 1, 0. 1, 0, 1, 0. You're like, okay, that makes it easy to remember. Yeah. What you do need to remember is the next one. Look at this one. What is the base? 2, so that's why it starts at 2, 1. What is the base of this one? 10, that's why it starts at what? 10, 1. What is the base of this one, everyone? E, that's why we start, the next point is at E, 1. What is E? 2.71. See, 2.7 and 1. That make sense? Yes? All right. But to get started with our practice, I'm going to start with our transformations being this one. But you're like, transformations, Mr. Q. Yeah, which means we need a general rule, yes? You guys remember our general rule? Yes, Mr. Q, we love those. Well, look at this. Before you copy, don't copy this one. You already know this one. We already know what K does. Is that correct? H, A, and B. Is that correct? Yes. However, let's apply that to logs. Copy this. G of x equals A log B x minus h plus k. And once again, k still goes up and down. H still goes side to side. A stretches or compresses vertically. B stretches or compresses horizontally. However, look up. For H, I want you to write that for this one, we're going to be using it also as our VA, because it's the inverse of an exponential, right? The exponential, we use the K. For here, we're going to use the H. Once again, we're going to be using our H as what? As our VA as well. Okay? All right, everybody got it? Yes, Mr. Q. All right, so let's get started. Example number 5 on our road trip through logarithms. Copy this one. G of x equals log 2, parentheses, x minus 5 plus 3. On the side, make a little coordinate plane. Make sure you make it nice and scaled. I'll give you a little bit more time for that, because we're going to be doing like about 3-4 transformations on this one right now. Copy that? All right, y'all ready? Here goes the process for tonight's home play. Step 1. You look at the transformation that they're giving you. They're asking you to graph it, which implies that you need a parent function. What would be the parent function for this one? Talk to your neighbor. What would be the parent function? Parent function. What would be our parent function, Lorena? Log 2x. That is correct. To graph this, I need my VA, which is x equals 0. So let's plot that. There's my VA, x equals 0. And we need 3 points. Tell your neighbor the 3 points for that parent function. All right, Jessica, our 3 points for that parent function. 1, 0, 2, 1, 4, 2. Let's go. That is correct. All right, now that we have our parent function, let's look at our new transformation. Tell your neighbor where we're going to move these 3 points to according to that. Where are we going to move them to? Where are we moving those to, Christina? To the what? To the right and up. Yeah, 5 to the right and 3 up. However, we need our new VA, x equals. What's our new VA, Caleb? Five. Let's go. So at 5, let's get our new VA. And we move each of these points 5 to the right, 3 up. So we go 5 to the right, 3 up. This one, 5 to the right, 3 up. This one, 5 to the right, and 3 up. 1, 2, 3. And there you go. From 1 to 5, how comfortable are you with that so far? 5 fours, 5 fours, okay. Let's do another one. Write this one in red. G of x equals log 2, parentheses, x plus 4 minus 5. Do we need to graph the parent function again? No, it's already there. So you know where we're going to move this one to, and what's our new VA, and get started with the graphing. Our new VA. All right, our new VA, Dulce. -4. Let's go to -4. And where are we moving this one to? Jaden. Four to the left. 5 down. Okay, so each of these points, 4 to the left, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. How we doing? From 1 to 5, how comfortable are you with that so far? All right, 5, 5, 5. So, okay, let's do one more on that same one. In green, G of x equals log 2 parentheses x plus 2 close parentheses plus 4. So you neighbor the new VA, and we're going to move that 2. New VA, and we're moving that 2. All right, Fabian, new VA. VA x equals -2. And where are we moving this one to, Lysandra? 2 to the left and 4 up. And we don't need to graph the parent function, so we already have it there. So we go 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. And there you go. Not bad at all. Okay, from 1 to 5, how comfortable are with these? 5, 4, 5, 4. Okay. Let's crank it up a little bit, yeah? Copy this one. Example 1, super Q. It says graph g of x equals 3 log base 2 x minus 4 plus 5. Now your coordinate plane doesn't have to be as perfect as this. Just do a regular coordinate plane, and let's start with our parent function. What would be our parent function, bless you? Christopher, parent function for that one. Log 2 of x, and our VA is x equals 0. And my 3 points, valente for the parent function. 2. 2, 1. And 4, 2, okay. All right, that's my parent function. All right, so where are we moving this one, guys, everyone? 4 to the what? To the right and 5 up. What is my new VA? X equals what? Caleb. 4. Let's go. Caleb in the house. There we go. However, look up, guys. We can't move it. Why not, Mr. Q? Because now we have this. Look up or you're going to miss it. What does that do to our parent function? It stretches it, right? So we start with 1, 0. That stays the same. However, look, instead of 2, 1, now we're going to be at 2 what? 2, 3. That is correct. And then the next point is 4, 2. Instead of 4, 2, we need to be at 4 what? 6. That is correct. So that's stretched. Did it stretch? Yes. And now we move this point, and this point. How many steps? 4 to the right and 5 up. 4 to the right, 5 up. 4 to the right, 5 up. 1, 2, 3, 4, 5. This one, 4 to the right, 5 up. 1, 2, 3, 4, 5. All right, how we doing? From 1 to 5, how comfortable are you with this? All right, 5, 5, 5, okay. Now look at these next ones. Don't copy these. Just wanted to see, make sure we got the process down. Look at this one. Look up. Pay attention to this one or you're going to miss it. You have some of these in your home plate. What's the first step? Oh, we need a parent function. Tell your neighbor the parent function for this one, please. Fx log x. However, what is our base? 10. That means my points are 1, 0, and 10, 1. What is our VA? Our VA is x equals 0. And the rest is history, yes? All right. Look at this last one. Tell your neighbor the parent function for this one. F of x equals what? Yeah, ln x. However, the base, we're going to use what? E. That means my point is 1, 0, and 2.711 right there. And of course, our VA is x equals 0, and the rest is history. Yes? I'll stop right there. Once again, your home plate for tonight, I'm going to upload it a little bit on Canvas. Also, make sure you get those screenshots signed in regards to letting your parents know that you have the study guide a full month ahead. Full month. Enjoy your home plate. See you guys tomorrow. Bye.